Hello, my name is Bruno and I'm the CTO of Materian, a cybersecurity company. And I'm here to talk to you about how a vulnerability hack might happen. So we will see a concrete example and also how you can possibly prevent it. Now, a few words about me. I'm a developer since 1988, so I'm a technical guy. I started in C and assembly. I was an XP coach in 2000, and XP means extreme programming. So I know agile methods, so to speak. I'm a Java champion from 2005. So yes, you can guess that my favorite language is Java indeed. And I'm the co-founder of the Java user group Torino, which is a Java user group that had its days and still going strong. And now, as I mentioned before, I am the CTO of Materian, which where we do application security. Hence, my presence here to talk about these problems. Uh, what we're gonna do a review of some past hacks, just to give some context, just a couple. We'll just have a look and understand what is a vulnerability. We will also have a look in general third-party components and in particular open source components to understand how they're used and why they're used. And also we will see now after that a live exploit. So I have a small server running on my machine. We'll see how an exploit can be executed. We also see some preventative measures. So we present what is available in Finos, and also I will present a project we are working on, which is completely free, and which we hope to integrate with one of the Finos projects. And then some conclusion in QA if you need them. Right, first start, some past hacks. So this first one, again, they're all in the past for a reason, because now they're not disclosed so friendly as before. But yeah, this is in 2017. The Canada Revenue Agency was hacked. So they didn't disclose exactly what happened. There was a full shutdown on the website used for filing taxes for 3 days. So the Canada Revenue Agency is the equivalent of Her Majesty here. And basically for 3 days the site was stopped, and this was done exploiting a vulnerability of a very common component used this day, a Java component, which was called Apache Struts 2, which allow attacker to execute code remotely. Then we go to look at another famous hack, which is the one for Equifax. So Equifax is a credit rating company, the biggest credit rating agency in the US and UK. Hundreds of millions of citizens were impacted, around 150 million. Also here in the UK. Things like consumer name, social insurance number, birth date, addresses, credit card information, and in some cases also driving license number were collected. The hack was admitted only after 2 months. And overall, between settlements and, repayment, I was hacked and they gave me like protection from hacks for 3 years. Anyway, they spent 1.3 billions. So that was quite the number. And this was caused again by the same problem in the same component. And it happened, as you can see, 2 months later, after it happened to the Canadian Revenue Agency. So 2 months. And then the same component was exploited in multiple places. So in multiple basically nations. So we have Okinawa Power in Japan, India Post, the EAPFO seeding platform in India again, University of Delaware, the payment gateway in Japan, and then again Alaska Airlines here, and a lot of more that I have. But again, was the same nasty problem in an open source component called Apache Struts 2. And it was a relatively easy hack to perform because you basically need, we're going to do one more complicated today, but this was extremely easy. You just need to call an API, any API exposed by this system, passing a header. And this header just need to contain a specific language, which is called OGNL, which is a presentation language used internally by Struts. And basically using OGNL, you can cause remote execution. You can basically exercise control on the remote machine And of course, when it happens, when you have control on the remote machine, you install a backdoor, and then in a second, you go there and you start. Well, maybe not in a second. You probably stay there for a while. I'm not giving suggestion here. I'm just telling how it happens. You stay there for a while, make sure that you're not detected, and then maybe after a day, you start quietly downloaded very slowly the data on your servers. So that's a way to do it, and that's how it was done in all these places. Yeah, again, just an explanation is an issue in the Jakarta multipart parser. You just need to send a little bit of header. You have 3 headers actually. You can choose. You have an option. You want content type, content disposition, same, and that's what it needs. And this same vulnerability reappeared 2 years later as CV 2019-0230, and again it was just another injection of code. So someone may ask now, why are we using external components that are so dangerous? Well, because we need them. But so first, you want your team to deliver software fast. So you cannot build a house. Imagine building a house, but having to work with raw materials. Just you have to construct everything from scratch. Windows, door, even bricks. You have to build them from scratch. That's not possible. You buy them pre-packaged. And the same happens for open source. You don't want to build everything from scratch. You just keep basically using components that are already present on the market. Another reason is that you don't want to spend money rewriting code that is already available. So you need to send an API, send an email, expose an API, connect to a database. Those are very basic things that, yes, once we used to code ourselves from scratch, but now you don't have to. So why would you? You don't want to reinvent everything from scratch. No, it's everything there. The diagrams are there, how to use it, documentation, everything is there. You don't want to redo these things. And then you may want to use state-of-the-art algorithm. So you don't have a genius that you can wheel out from your premises and, I don't know, do a quantum resistant cipher algorithm. No, you pick one. They're already there in open source. There are plenty. So what happens is that then your application is then composed by 20% of the code that your developers carefully produce. So very well monitored, peer reviewed, blah, blah, blah. But then you have 80% of open source of components coming from somewhere that some other people wrote. And don't get me wrong, those are usually really, really good and are patched very quickly. But the problem is that everybody can see this code, and you have to keep your code up to date very, very continuously. So what is a vulnerability then? A vulnerability is generally a weakness that you have in any code, and specifically when it's a vulnerability from an open source component, it's usually listed very quickly in one of those. On the main databases, we have the NIST databases, famous because it was the first one, much popular, that has the CVE notation, CVE year and number. Then you have the Google OSV database, OSV XXX, MAL XXX, and the GitHub advisory database, GHSA XXX. And then there are a lot of other OSINT sources, because of course not all the languages are listed here, and sometimes some languages are only in some remote databases that are not available to everybody. So how many are there? In 2024, we had more than 100 new vulnerabilities every day, 100 every day. So I usually here I can show you, we record those daily from our website. And here this is the menu of the day. No, this is just today. This was just Sunday, Saturday, Friday, Thursday. So you can go back. Eventually I might find a day where we don't have any, but it's going to be very difficult. So the problem is that you have a lot of them, and not a lot of them are patched. So what happens is that the open source community quickly put out a fix, but then this fix have to be introduced in all the application that you have. And there are a lot of reasons why your vulnerabilities are not patched because you cannot track them, you don't have time, you don't know where you're using that component, you don't have the resources. There are a lot of good excuses and real problems to this. So I just want to show you quickly a remote code execution here. And then we're going to use a vulnerability in Jackson data bind. Again, very old one, CV 2017-7525. But this chain of vulnerability went up for 2-3 years, I think, because the developers weren't able to fix it in a way that was really good. So we kept having vulnerability on Jackson Database for a while. And I can show you very quickly. So here I have some code. Maybe some of you are familiar with code. So we basically have a REST application that basically is entirely written in Java. It's all good. You have the link at the end of the presentation to see the code. So there's nothing strange here. And I have basically the server running in one window here. Let me just, no, not you. We have the server running in one window here. This is the server. I just run it. No, I can run it again. It's very simple. Voila. I run the server. And the server, there's APIs here that I coded with curls where I can call the server. So for example, here I can call an API called list that will basically invoke the server over HTTP. Imagine this is the server is on your premises somewhere in Canada, and this guy, the gray guy, is in China trying to hack your server. So you can see, and the API goes over HTTPS, all fine, secure, fantastic. I do the call, and here we go. And here we just executed an API and get the list of products. No, and I can also add a product. There are other APIs. I can add the product here. So in this case, I added a melon from Italy. Yeah, because in Italy we have real fruit, not the strange thing that you have here in UK. So we do add the melon from Italy, and then I can ask a list again, and then the list contains the melon. You can see this is the server responding. So whenever I call an API, the server responds down here. This is the response of the server, and this is the client receiving such response. But what I can do here, I can also run an exploit. So what I did is I created a Java class previously, which again is available. And the Java class basically does this. So it's a Java class that basically it basically prints something. It's nothing nefarious. And this Java class is then encoded just compiled, and the code is then encoded in BinX and put it in a JSON format that is compatible with the API here. And now what I can do, I can invoke the exploit from here. So this it's me in China. Boom. You see, I executed the API. The server basically went doolally. It didn't understand exactly what's happening, but in the meantime, my code was executed. And you can go online on the website and see how this works. But it's very dangerous. I really sent a JSON message just with some code in it, and the system executed it. Now, what can we do to prevent this? That's a good thing. So first, you have to scan continuously your open source estate. So you have to make sure that you know what open source are your application using, and then also make sure that you're patching it, so you're upgrading when required. And Finos have two good things to do that. Finos have the Finos code scanning, which is a suite of tools that you can put in your pipeline on GitHub, on Bitbucket, whatever you use them. Probably on GitHub only, but they're easily to adapt on Bitbucket, on other systems. So you can just use this thing that will continuously scan your code and tell you if you're using any vulnerable component. And then you have Git proxy, which is another good system, which is basically used to it acts as a check before the developer push the code to the server. So before the developer pushes the code to the server, Git proxy can intercept the push and do something about it. And that's a project we want to collaborate with Finos, because we have something that can help. So we do this. So we are an application security platform, and we are keen to donate back to the open source community in general. And what we want to do is contribute to this project with something that we have, which is an ability to detect quickly if you're using any vulnerable component right away at the moment of the push, and we can integrate it in Git proxy. Actually, we already did something even earlier. So we have an IDE plugin, which is actually free. We don't track anything, completely anonymous. The code is there, examined, put into a proxy. So we had the same API that this plugin is used, will be used in Git proxy. And the plugin is really, really powerful because it works inside the development and the integrated development environment that developers use. So it's really, really simple for developers to use. At the moment, we deployed it from Visual Studio Code, and we're going to release it also on JetBrains Um, we do have, of course, a paid version of this, but you don't have to pay again. It's completely free, and we do it because we want to increase the awareness of this problem, and we want to give back. So also here, a quick demo. So I'm a developer, and this is basically, okay, this is basically the Fruit server, the code that I did before. So I already installed the plugin, but it's really one click. So when I open this, the system will run automatically and will find problems in this code. So for example, here, it did detect a vulnerable component. So let's call this is not related. I don't need to update. So you can see here, it tells you material security has detected some issues. So you have the problem here, and you can see two problems, one here, one here. And what you can do, you can basically click here and upgrade this particular component, this patch, and voila. And this is gone. So this is how, okay, I'm missing a tab, but I can do it. That I can do, that I can do. Off you go. So this is something that is very useful because it gives the power to the developers. It's the earliest that you can do this check. And it's also very useful because if a developer finds a problem early, for him it's very easy to fix it. Otherwise, if you let it go through the pipeline, maybe it is not detected early, then you start using that component massively, it's difficult to correct. So this was a Java project, but we can do the same on another don't save. Okay, let me say this one. This is Python, I guess. Yeah, this is another one. This is a Python again. And the same thing happens. So I run the scanner runs, found problems, and then I can fix them. So, no, from here. I can also see a lot of information. So here I can see basically the problem that it did find, and I can go and examine the package, and I can have a lot of information here. But basically, what developer is lazy, just want to do this. Off you go. Bye-bye, resolved. So that's what the developer would do to solve this issue. So this is basically what I wanted to tell you today. I think I've stayed well within the 20 minutes. We would have another 2 minutes for questions, but I hope you caught the gist of it. So your developers are using a lot of open source, and that's absolutely normal and is very good. You have to put this open source under control. You have to put checks in order to make sure that the open source, it doesn't become a threat because it's a large attack surface. And then you need to have tools in place. And again, Finos code scanner, Finos Git proxy. We will contribute our contribution to Finos Git proxy to put also the detection there. And again, if you want to use the IDE, it's free. We're not tracking anything. Use the IDE, but do something because these problems are real and are very difficult to catch, and they can bite you back very hard. So good luck out there and be safe. Thank you for your time.